Alkyl halides. As the name itself suggests, it contains halogens like fluorine, chlorine, bromine, iodine, which is attached to alkyl group. R is the alkyl group. If we consider halogen as X and R is alkyl group, Rx is an example for alkyl halides. If you have CH3 instead of R attached to Cl, it is called as methyl chloride. The functional group is X, here in this case Cl. Alkyl halides, as in case of amines, can be classified as primary, secondary and tertiary depending upon the number of R groups attached or methyl group attached. If you have R, this was the general formula, that is CH3L. If I replace one of the hydrogen with R and remaining two hydrogens are as it is with Cl, this is called as primary alkyl halide. If I replace another H by R, then it is RCr with hydrogen and Cl. This is secondary. If I replace the remaining hydrogen, then it is RCrRCl. Then this is tertiary alkyl halide. So alkyl halides are one of the most important functional group for preparation of various pharmaceutical preparations. So in that is when we are trying to see the method of preparation. We have already seen in alkanes halogenation. It is, if I take CH4 and react it with halogen in the presence of H mu, that is sunlight, it gives us CH3Cl plus HCl, and further it will give us CH2Cl2, CHCl3 or CCl4. These are all the products obtained based upon the concentration of Cl2 and CH4, which we have already discussed. Please try to refer to those notes if you don't remember that. But in the method of preparation, the first one is halogenation of alkane, where alkanes are going to react with halogen in the presence of sunlight or at higher degrees like 400 degrees Celsius to give alkyl halides or polyhalogen derivative. These are polyhalogen derivatives. This is one halogen, this is two halogen, this is three, this is four. So when you have more than one halogen, then it is called as polyhalogen derivative, which is already mentioned in your notes. So in the exam, they may ask you write the what are alkyl halides. You need to write down the definitions which will be there in your notes, along with this representation of primary, secondary, tertiary, and then we have to move to the method of preparation. First method of preparation you have seen is halogenation of alkanes. Next is addition of halogen acid. Halogen acid is HX, or X is halogen, to alkene. So alkene is, if I'm going to use here ethene, that is CH2 double bond CH2, it's going to react with HCl to give, this will go here and this will go here, and this bond will be broken in the addition reaction. Then it will be CH3 single bond CH2 Cl. This is ethyl chloride, which is a alkyl halide. So you can even use propane also. For instance, propane is CH3 CH double bond CH2 reacts with HBr, is another halogen acid. Halogen with hydrogen together is called as halogen acid. So hydrogen will go towards CH and Br will go here as per Markovnikov's rule. Please refer to Markovnikov's rule if you don't understand the analogy which I am telling you. It is CH2 single bond CH2 Br. In addition reaction, this double bond is broken. Right. Mm, in the chemical properties, the type of reaction which alkyl halides undergo are substitution or elimination and reduction reaction, but preferably or mostly the reaction which they predominantly undergo is substitution reaction. Uh, as you very well know, if you are talking about CX with HH and R, this is primary halide. The alkyl halide is polar due to difference in the electronegativity between carbon and halogen here. That is the reason X will have partially negative charge and carbon will have partially positive charge. And because carbon is having positive charge, they are more prone to be attacked by a nucleophile. It is Nu having negative charge. So the carbon halogen atom in alkyl halide is polar. The carbon atom is therefore a good target for the attack by nucleophile. Why this is polar? Due to difference in the electronegativity between carbon and the halogen. And due to higher electronegativity of halogen, it will have negative charge and thereby carbon will have positive charge. And because of this positive charge, nucleophile which are negatively charged will be attracted towards carbon having positive charge. So when the substitution reaction is happening and it is attacked by a nucleophile, that reaction is called as nucleophilic substitution reaction. And this nucleophilic substitution reaction is the characteristic reaction of alkyl halide. So what happens here if we are trying to represent, have R, C, H, H, and here NO will be coming and X will be removed. So this is your nucleophile which is incoming. This is alkyl halide. This is substitution product. And this X or halogen is your leaving group. So something is incoming and something is leaving. The incoming is nucleophile, the outgoing is the halogen. So this is why this reaction is called as substitution. The incoming species are nucleophile, it is called as nucleophilic substitution reaction. So when when a substitution reaction involves attack by a nucleophile, the reaction is referred to as nucleophilic substitution reaction, which is represented as SN, where S stands for substitution and N stands for nucleophile. Nucleophilic substitution reaction is divided into two types. It is SN2 reaction and SN1 reaction. SN2 reaction and SN1 reaction, we'll discuss it separately under different headings, and then finally we'll try to differentiate between SN1 and SN2 reaction. Whatever we have discussed is important for your upcoming semester exam, which is where they may ask you about write down about SN2 reaction, SN1 reaction. So I'll discuss SN2 as well as SN1 reaction separately. Thank you.